By default, our Cisco Catalyst switches are going to be running PVST Plus, per VLAN Spanning Tree Plus, as the spanning tree implementation. And I've got these connected as we see here, and we want to go in and verify that the switch we think should be the root bridge really is the root bridge, and same thing for the root ports and the designated ports and the blocking ports. Let's make sure our paper exercise translates to the real world. We'll show you how we can go into these switches and glean information about port states and who is the root. And this can be really helpful when we're doing troubleshooting. In fact, let's go ahead and predict who we think is going to be the root bridge. Assuming that all the priorities are at their defaults of 32.768. Based on this topology, you might want to pause the video and think about this as you look at the MAC addresses. Who do you think is going to be the root bridge? You might want to pause the video. Now, let's think about this. It's the lowest MAC address if the priorities are a tie. Who has the lowest MAC address? It's switch C. Switch C has the lowest MAC address, and if the priorities are equal, that means that switch C is going to be the root bridge. The next question we ask as we're analyzing a spanning tree topology is, what are the root ports? Remember, every non-root bridge has one and only one root port that is closest to the root in terms of cost. If we look at switch A, we've got a couple of gig links up to switch C. The cost of a gig link is 4. If we went over to switch B over that 100 meg link and then came up from switch B to switch C over another 100 meg link, the cost of a 100 meg link is 19. So that would be 19 plus 19. That would be a cost of 38 as compared to a cost of 4. So obviously, the root port on switch A is going to be either gigabit 1/0/13 or 14. Which one though? If it's a tie, it's going to be the lowest port number. So we're going to predict that gigabit 1/0/13 is going to be the root port on switch A. What about switch B? Well, we've got a direct link over that 100 meg link directly up to switch C. That'll have a cost of 19. That's what we're going to use. That's better than going over a 100 meg link to switch A with a cost of 19, and then going from switch A to switch C over a gig link for a cost of 4. That would be a total cost of 23. We've now predicted our root ports. Next, let's predict our designated ports. Remember, every segment has a designated port. We've got 4 segments. We're going to have 4 designated ports, and 3 of them we know instantly because all of the ports on our root bridge are going to be designated ports. The designated port is the port on a segment that is closest to the root in terms of cost, and we don't get closer to the root than actually being on the root. The only segment that's in question here is the segment between switches A and B. Which side of that link is closest to the root? Well, I'm going to say it's the side on switch A, because switch A has a cost of 4 to get to the root, switch B has a cost of 19 to get to the root. Let's predict that gigabit 1/0/15 is going to be our designated port on that segment. All of the other ports are going to be blocking ports. That's what we're predicting we'll see in this topology, but we'll go out live in just a moment and verify this. After we do the verification, let's change things up just a little bit. Let's say that we want, for optimal flow, we want switch A to be the primary root bridge for VLANs 100 and 300, but the secondary for VLAN 200. And we'll say that switch B, we want it to be the primary root bridge for VLAN 200 and the secondary for VLANs 100 and 300. Prior to this configuration, switch C was the root for everyone. Even though we were running PVST Plus, where every VLAN can have its own instance of spanning tree with the default settings, yes, we have multiple instances, but they're identical. Let's go ahead and take a look at our next video now, and we'll see if our predictions were correct as to who is the root bridge, what are the root ports, what are the designated ports, and who are the blocking ports. We'll see you in the next video.